V curve is a plot of stator current versus field current for constant load in synchronous motor. These are called V curves as the shape of these curves is in the form of a letter V. On right side, power factor is leading and on left side, power factor is lagging. How do you explain this? The internal resistance is neglected as it is very small as compared to synchronous reactance. V is equals to E plus JIA XS. Based on above equation, phasor diagram of synchronous motor is drawn. Since load is constant, power is constant. That is, VIA cos phi is constant. In a grid connected motor, V is constant. Hence, IA cos phi is constant. That is, tip of phasor IA can move in a straight line only. Phasor of IA axis moves perpendicular to IA. In case of synchronous motor, applied voltage V is taken as reference and IA axis is subtracted from V to obtain E. When current changes from lagging power factor to unity power factor to leading power factor, tip of IA axis moves right and EMF increases. EMF is proportional to field current. Thus, armature current changes from lagging to leading with increase in the field current. This explains why right side of the V curve is leading and left side is lagging. In the backward curved radial fan, in the normal operating range, pressure discharge of fan is drooping or rising. In the fan, increase in pressure delta P generated by fan is more important. Delta P versus discharge characteristics of fan is drooping in the normal operating range. That is, delta P decreases with discharge Q. However, system characteristics is rising. That is, delta P increases with discharge Q. The point at which these two characteristics intersect is operating point. Discharge of air in motor is Q1. The required discharge Q1 is calculated from the losses in the motor. The fan size is decided based on the required discharge. In case discharge required is more, higher size fan is used, raising fan characteristics. Thus, discharge in motor increases. In a very large size motor having high speed, which bearing is suitable? Rolling bearing or sleeve bearing? When size and speed of motor is very high, rolling bearing not suitable and the sleeve bearing is used. The pedestal is fixed on the base. Sleeve is fixed inside the pedestal. Advantage of fixing sleeve is that only sleeve is required to be replaced after it wears out and pedestal is not damaged. The rotating portion of sleeve bearing is called journal. When journal rotates, lubricating oil is pulled below journal and the journal is lifted up. Weight of the rotor is taken up by lubricating oil. This process is called hydrodynamic. The sleeve bearing has got following advantages. The lubricating film prevents metal to metal contact which reduces friction and wear. It also reduces vibrations and noise. It has got low cost, easy installation, high load carrying capacity, and long life. Why jacking oil system is used in sleeve bearing. During starting and stopping of generator, speed of general is very low. Oil film is not formed between journal and sleeve, and wearing of sleeve takes place. The jacking oil system refers to a high pressure oil system used to temporarily lift a rotating shaft slightly off its bearings. It is used during startup and shutdown by creating a lubricating oil film between journal and sleeve. In medium-size AC machine, normally ball and roller bearing is used. Ball bearing is fixed. However, rolling bearing is floating. Why floating bearing is used? The floating bearing is used to accommodate differential thermal expansion of shaft and housing. Deep groove ball bearing is non-separable and rolling bearing is separable.